The Nintendo Entertainment System's motherboard is built around two key proprietary chips from Ricoh, the CPU and the PPU, which handle all the processing for gameplay and graphics. The rest of the board provides the supporting hardware to make these chips work, including memory, power management, and the cartridge and controller interfaces. Key components: CPU, Central Processing Unit. The NES uses a Ricoh 2A03 processor, or the 2A07 for PAL systems. This is a modified, unlicensed version of the MOS Technology 6502 8-bit CPU. Its modifications include an integrated APU. The CPU contains the audio processing unit, or APU, on the same die, which handles all 5 sound channels. The no BCD mode, also the MOS Technologies 6502's binary coded decimal mode was actually disabled, possibly to avoid patent issues. And the I/O registers, the chip includes memory mapped registers for direct communication with the PPU, controllers, and for DMA, that is direct memory access. So the PPU, or the Picture Processing Unit, is the Ricoh 2C02 PPU, or the 2C07 for Europe and Australia, or the PAL, is a separate chip. It is, and it's dedicated to generating all the video and graphics. It has its own dedicated memory and address space for tasks like rendering sprites and background tiles. Now for memory, the main board includes actually 2 types of RAM. You have work RAM, or WRAM, and this is a 2 kilobyte chip used by the CPU for general purpose data storage. And then you have VRAM, or video RAM. This is a 2 kilobyte chip used by the PPU to store name tables and attribute tables for the background. And then we have this other component. This is the 10 NES lockout chip. This is a crucial security feature that prevented unlicensed games from being played on the console. A master lockout chip in the NES communicated with a slave lockout chip in each licensed game cartridge. So if the chips couldn't handshake properly, the console would enter an endless reset loop, causing the screen actually to flash. This is a common cause of the blinking screen problem on older NES consoles. There's also the supporting of circuitry, if we are talking about the motherboard, giving a general overview of the motherboard. Power and reset. So the motherboard includes, actually, when it comes to power and reset, a voltage regulator, typically an AN7805, to convert the incoming power to the 5V DC required by the chips. The reset circuit is also tied to the 10 NES chip, which controlled the physical reset button. And there's also the cartridge connector. So the NES's 72-pin front-loading connector, unfortunately, is a well-known point of failure. The design and its frequent use led to bent pins and poor contact, actually causing games to fail. There's also the controller ports when we're considering the motherboard. 2 controller ports are wired directly to the CPU's input-output pins, which read the controller input data in a serial fashion. There's also an RF modulator. So early models of the NES used an RF modulator to output video and audio signals, which were sent to the television's antenna input. Later revisions of the board added what's called direct composite video output.